This year is the 500th anniversary since the death of a great Italian genius, Leonardo. Leonardo was the first one with his book about how birds were able to fly to understand that it's not magic that hold birds in the sky, but precise and controlled movements. So my talk will focus on technology, the future of technology, because technology has fulfilled the dream of Leonardo to send humans to soar the sky. The Wright brothers invented the first flying machine. The Soviet rockets brought humans to space. This year marks also the 50th anniversary of the human landing on the moon. It has been a challenge for whole humanity, and the scientists from many different fields were together toward this unique goal, and they developed and conceived new things and new technology. The beneficial technological effects, let's say, from the space race to the moon were so enormous that are even difficult to quantify. One for all, it is satellite and wireless communications that now we use in our everyday life, but it was originally invented to allow humans to set their foot safely on the moon. I'm a scientist, an astroparticle physicist, and for the last 25 years, I'm developing, designing, building, and using instrumentation able to identify high-energy particles. These particles can damage DNA and can trigger cancers. So my contribution to the space race is to model this flux of high-energy particles and to mitigate the effects it can have on astronauts while in space. Because altogether, step by step, Leonardo, the Wright brothers, the Soviet cosmonaut, the Apollo missions to the moon, we are all heading toward our next target, Mars. I guess you guys of TEDx have heard a lot about Mars, either because for the search for extraterrestrial life of Mars, the search of water, liquid water on Mars, or because you were just following some robotic mission to Mars. Okay, today I will touch on a different subject, another reason why to go to Mars beyond mere curiosity. The other reason is because when we go to Mars, we will be able to retrieve key resources for our technology. But first of all, let us understand the challenges in going to Mars. So, first of all, in this picture you can see in scale the Earth, the Moon, and Mars. You see that Mars more or less has a diameter that is half the diameter of the Earth. The Moon has half the diameter of the diameter of Mars. So if you take into account the distance between Moon and Earth is so small if compared to the distance between the Earth and Mars. In fact, to go to the Moon, we just need 3 days. But to go to Mars, we need 6 long months. So this will be a big difference, because in the meantime, after 6 months, the relative positions of the Earth and Mars have substantially changed. So this will be a little bit tricky. After all, we are talking about rocket science. But, you know, I think you guys at TEDx will go the extra mile and follow my reasoning. So I prepared some very easy animations so we see what we are talking about. So 1 Mars year is 2 Earth years. It means that to go back to the same position in the sky with respect to the Sun, the Mars has to wait 2 years. So we can follow it. So we put Mars and the Earth on the same side of the Sun, and then we let then go. So after 1 year, the Earth is back to the same place, but Mars is on the other side of the Sun. So at the beginning, they were aligned, and now they are completely off. So we let them go, and Earth, little by little, catches up with Mars and realign with it after 26 months. Alignment are perfect to send humans to space, because the path between the Earth and Mars will be the shortest one. But as it takes 6 months to go from the Earth to Mars, you have to launch the rocket 6 months ahead of the alignment, or more or less here. So we follow them again. So we see that it gets there exactly during the alignment. Then they have to stay for 20 months, more or less, to Mars, just in time to send back the rocket to Earth with 6 months ahead of the alignment. So you see, overall, it takes more or less 6 months to go to Mars, 6 months to come back, 20 months for the realignment. So now the difference between a mission to Moon and the mission to Mars is obvious. To go to the Moon, back and forth, 3 days, 3 days, 3 days there is more or less 10 days. But to go to Mars, you need to stay in space for at least 2.5 years. That is a lot. It could be a formidable ordeal for every astronaut there, mainly because you are not shielded by the magnetic field of the Earth. So why it is so important, the magnetic field? Well, you see, our Sun, in addition to light, emits many high-energy particles that make up the so-called solar wind, one of the aims of my research. During their travel from the Sun to Earth, they are bent by the magnetic field of the Earth and are diverted toward the poles, where they lose the energy and produce something like this: northern and southern aurora. These amazing views are powered by the energy lost by the particles, by those particles making up the solar wind, that in such a way do not reach Earth and do not harm us. But Mars does not have a magnetic field. So during their travel to Mars and their permanence on Mars, astronauts will suffer the full blow of solar wind. So they will be exposed to these particles that can damage their DNA. So my mission now is to help mitigate the effect solar wind has on space travelers in such a way that they can set their foot on Mars as safely as possible. But you know, if it is a long journey and a very difficult journey, why we should go to Mars? Well, one of the reasons is that, we Terrans, inhabitants of Terra, the planet Earth, have always wanted to push further our limits. We always wanted to discover new lands beyond seas, beyond mountains, and why not, beyond space. So in a way, Mars will become our next frontier. So Mars is the new challenge, and we think that the new space race to Mars will mirror what exactly happened for the Moon conquest. So when we went to the Moon, we had to conceive and invent new ideas. I quote the, let's say, satellite and wireless communication, but there were many technological advancements that were triggered by us trying to set our foot on Moon. The same will happen for Mars. So going to Mars will usher new technologies. In particular, it will usher new technology because some key resources will be available. So imagine now having a material that can withstand corrosion much better than any other metals. In addition, add to your picture the capability to maintain its shape and its mechanical properties up to 2,000 degrees Celsius. This material exists. It's called iridium, and it's part of the platinum group, a group of 6 metals that for technology are even more precious than gold. Well, all of the 6 are important, but we focus back on iridium because it is the champion of stiffness. So it is the ideal material to build crucibles where we can melt and give shape to high purity single crystals that are used in advanced technology in everyday life. So wireless and satellite communications, high definition TV screens, laser beams, X-ray scanners used at airport security, or medical scanners. All of them are based on iridium technology. So in a way, iridium availability is naturally related with technology. The problem for iridium and all the material, all the metals in the platinum group, is they are extremely rare on Earth crust. Just 1 part per billion. So where do we have to look for it? We have to look for it on meteorites. Because if you just take a huge piece of stone, 1 cubic meter of stone, and you crush it to dust, you will just fetch 1 tiny millimeter of iridium. But on that meteorite over there, the Willamette meteorite, if you crush it to dust, you will be able to fetch something like few cubic centimeters of iridium, because iridium on metal-rich meteorites is 1,000 times more abundant than on Earth. So the question now, you can see it more or less in this picture right here. If this is the abundance of iridium on Earth crust, this is the abundance on iridium on iron-rich meteorites. So where can we look for meteorites? Well, actually, meteorites are small. The very big meteorites, we call them asteroids, and there are plenty of them around them. As a matter of fact, the only real, let's say, mining place on Earth for iridium are situated near impact craters, where asteroids hit Earth millions or billions of years ago. So where do we look for asteroids? We can look for them at what we call the asteroid belt. You see there are so many dots over there, and the asteroid belt that contains so many asteroids, it is located just outside Mars. So this is the orbit of Earth, this is the orbit of Mars. So now you are sort of understanding where we're heading to. But let's say, if you take 1 metal-rich asteroid of 1 kilometer of diameter, how much it is worth? Try to guess it. It contains a lot of precious metals, and if we take all the precious metals to Earth, it will be worth 13 trillion US dollar. That is 13 million of millions of US dollar, or more or less the entire GDP of China in 2018 in just 1 single asteroid. By the way, 1 trillion US dollar is just what more or less a mission to Mars will cost. So we go there, we retrieve an asteroid, a very big asteroid, and the first investors will gain gazillion of dollars. But what do we people on Earth will gain? Taking these asteroids, we will get a lot of important material, a lot of key resources like iridium and all the other metals of the platinum group. So we gain because this material will let technology be available at a lower cost. So we all gain because we are expecting a new leap in technology. But why do we have to go to Mars to do that? Well, the reason is that, okay, it is more abundant on asteroids, but not so abundant. So it is better to pre-process them, because only 1 part in a million of asteroid is just precious metals. So Mars is the ideal place where we could pre-process this asteroid, just because it is closer. So it will act as a nice outpost for asteroid mining. So the idea is that mining crew we start the stint from Mars, we go to the asteroid belt, pre-process the elements, take all the rare material, the precious materials back to Earth, and that is it. In addition, Mars is a good place because it has a low gravity and a low atmosphere. So low friction and low gravity means that you need to spend only very low energy to send the rockets from space, from Mars, with respect to Earth. Another thing is that Mars can provide a larger habitable environment to the miners that can work there. So you see now that everybody is gaining. So the miners will earn a lot of money, big money, so they will come to the Earth rich after the stint on Mars. The investors will have a return, and we on Earth, we will have a new leap of technology. So I think you are all looking forward to invest in asteroid mining, don't you? But you know, are there any vulnerability? Well, vulnerability lies on the fact that we have to send human to space. We evolved to stay here on Earth, not to go to space. So space traveling makes us sick. So in a way, zero or low gravity will have a huge toll on our heart, muscle, bones, kidneys. So most of the money that we will put in our quest to Mars will be invested to solve these health-related issues. And that will have a nice fallout, let's say, also on us, because what is happening, the effects, let's say, of low gravity on our body, more or less, mimic what aging does. So, in a way, to conclude, I think that the new space race that will take us to Mars will speed up the technology also in the sector of health, so we all profit. In addition, it is profitable by itself because we can use Mars as a nice outpost to mine for asteroids. So everybody will gain, either directly because of a new technology leap or indirectly because of a new solution that have to be found to have humans set their foot on Mars and to work and to walk on there. So, in the common future that all humanity share, once again, setting our foot on Mars will be a small step, but a huge step for all humanity. Thank you.
Thank you, Denis.
I was perfectly on time.
Okay. Yeah, just like a moon landing, of Mars landing.
Okay, yeah.
I want to ask a question. Thank you, first of all, for providing this additional knowledge, because when we talk about Mars now, we think about, oh, we're curious, we are exploring, but now you provided this very practical reason that we are going to Mars. I want to ask you a question. So, in your imagination, because you're a scientist and you're working on this field, in your imagination, are we going to live on Mars one day, or are we going to stay on Earth and draw things we need from the space, or something else?
I think we are living on both planets, because if we have to leave Earth, it means we destroyed it. So I think we will find a solution to that too. So I think our future, we will live on both planets. We have to keep in mind that in a way we will evolve to stay just on one planet, because on Mars the gravity is so low that after a few years you won't be able to come back to Earth because you will be crushed.
Oh, okay.
So one or the other, probably.
Okay, well, we can keep traveling between these two, so...
Yeah, well, we need teleport before doing that.
Okay.
Yeah.
Thank you so much, Denis.
It was a pleasure. Thank you very much. Yeah.